Hello everyone, welcome to the course Computer Networks. This is S. Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about framing in data link layer. In previous session, already we discussed about what is data link layer, what are the different issues of the data link layer, what are the different types of the data link layer. All we discussed in previous session. Now we are going to discussing about what is framing in data link layer. First, let us see the overview of today's session. We have to discuss about what is framing first of all. What is framing? At the same time, what are the different types of fields are there in frame? Those are discussing today. And next, what we have to discuss about what are the different types of the frames. And next, we will discuss about the what are the different methods are going to use for dividing the particular frames. Those are like byte count, flag bytes with byte stuffing, flag bits with bit stuffing, physical layer by coding violations. Those all we will discuss in today's session. First, we will discuss what is framing. Framing is nothing but framing is a function. It is a function of the data link layer. Mainly, it is talking about it is providing the way for the sender to transmit the data to the receiver in the set of bits that are meaningful to the receiver. See here, it is a function. Mainly, it is talking about it is providing the way for the sender to transmit the data in the form of the bits that are meaningful to the receiver. That is nothing but framing. So, this frame consisting of the address of the sender and receiver. Whatever frame is there, that is consisting of the address of the sender as well as the receiver according to the destination address. Here is the source, there is the destination, right? So, receiver is nothing but the destination. According to the destination address, the frame will be sent to the destination based on the address. Means here we are providing the address in the node-to-node delivery only, right? That is one device to another device. According to the destination address only, the receiver receives the data. When the destination receives the frame, it opens the frame. If it receives the frame, it will check and it will open the frame and it will check the sender address. And it will give the acknowledgement to the sender. Yes, I received the frame. Like that, it will give some acknowledgement and has received the frame. Like that, the framing is going in between sender and receiver. At the same time, this how it is going to be happen in between sender and receiver. First, data link layer receives the packets. Whatever packets are coming from the network layer, that is received to the data link layer and from the network layer and that are converted into the frames. Whatever packets are that are converted into the frames, that is nothing but the frames. So, the data link layer splits these large frames. Whatever frames are coming here, that going to be split into the large into the small frames to maintain the flow of the data. Why it is going to be divided into the different frames means to control the flow of the data and reduce the chance of the error in between the devices. For that, we are going to divide the frames into the different small frames. That is about the framing. At the same time, what are the different fields of the frame here? Frame is consisting of the mainly three parts. What are the three parts here? That is header is there, data is there, trailer is there. Header, here is header, data that is also called as the payload field or packet and trailer. These are the three fields of the frame. At the same time, the frame structure and size vary according to the protocol being to be used. Whatever protocol is going to be used based on that we are going to. So here it is the right. So here whatever based on the structure and size, it is going to be based on the protocol. Whatever protocol is going to be used based on that, it is going to be changed the size of the frame. So it is consistent three, right? That is the header, payload field and trailer. First, we will discuss about what is header here. Header is nothing but it is consisting of, again it is divided into four parts. Those are nothing but the frame starting is there, addressing is there, which type is there and next quality control. This all comes under the header. So, first what is frame start? It is talking about the identify the start of the frame by looking at the frame start field. It is talking about the starting of the frame. Where the frame is going to be started. That is nothing but the frame start. And coming to the addressing, it is telling about the address of the sender and receiver. It is saying the address of the source and destination. Those sender and receiver address. According to the address field, the data link layer sends the frame from sender to the receiver based on the address only. This address only, the sender is sending data to the exact destination. That is about the addressing field. And next one is the type field. What is the main work of the type field? It is mainly used for the identifying the network layer protocol. For identifying the network layer protocol, which is going to be used for header information. For that reason, we are going to use the type field. And the next field is the control field. Where we are going to use these control field, it provides the flow control mechanisms. It is mainly talking about the flow control, how the flow is going to be, at what speed the sender is sending, at what speed receiver is receiving, all comes under the flow control mechanism. By using these control fields only, the network is prioritize the packets that are important for the communication, which packet I have to send the first for the communication, that is comes under the control field. These are the different fields in the header. And the next part is the data. Next field is nothing but the data field. This is nothing but the payload field or the packet field. It is talking about this is an IP packet received from the network layer. Yes, whatever data is received from the network layer, that's it is in the form of packets only. That is received from the network layer. These are known as the payload or data field in the data link layer. All protocols in the data link layer will be added to the frame data field. Whatever protocols we are going to using these particular data link, those are comes under the packet field. That is the data field. And the next one is the trailer. The third one is the trailer field. What is the main use of this trailer? So, error detection and frame stop are the fields of the trailer. So, here error detection and frame stop. These are the two fields of the trailer field. So, it is talking about the information will be added to the trailer of the frame. So, like here the error detection and frame stop is there, right? Error detection is talking about the trailer field of the frame contains the error detection method used to identify the errors during the communication. Means where exactly error is happening. Whenever the data is sending from the sender to the receiver, if suppose error is there, where exactly the error is coming, that is comes under the error detection. And coming to frame stop, it is saying about the identifying the end of the field, where exactly the field is going to be ended. That is in frame stop. These are the fields in the trailer. So this is about the fields of the frame. It is having three, that is header and packet field and trailer field. And the next topic is the types of the frames. What are the different types of the frames? So these are the two types of the frames. Fixed type frames is there. Fixed size, variable size frames are there. Fixed size frames. In fixed size framing, mainly fixed means the size is going to be fixed. The size is going to be fixed means whatever data is sending in a form of frames, that is fixed size. This is the fixed size. That is 1024 bits is the fixed size. Mainly it is used, the example for this is ATM WAN, asynchronous transfer mode wide area network is the example for the fixed size framing. The size of the frame is the fixed, that is the fixed size framing. Coming to example for this fixed size framing is, here 1024 bits is there, right? Whatever data is there, that is the size is fixed. So if suppose if any error is occur, in this particular fixed size frame, if any error is occur, the receiver device will check all 1024 bits because the size is fixed. That's why it will, if it is error is there, it will check all 1024 bits. So it will take time consuming for the receiver. That is the disadvantage of the fixed size framing. Coming to variable size framing. Variable size framing is nothing but entire message is going to be divided into some smaller size frames. So here whatever 1024 bits is there, those are going to be divided into some small part, like frame 1, frame 2, frame 3, frame 4, like 256 bits, 256, like that it is going to be divided, means variable size. So for each frame we have to define the start and ending of the frame. So for each and every frame, again we have to divide as the start and ending of the frame. So in this variable size framing, it is divided into how many types? 4 types of the frames. Each is having the 256 bits. So suppose in this field, in this variable size framing, if any error is occurred, instead of checking all 1024 bits, instead of checking all this, where the error is occur, in which frame it is going to be occur, based on that, it will check only 256 bits. Suppose if in frame 2 error is there, so it will check only these 256 bits only. Like that it is going to be divided. This is nothing but variable size framing. These are the two types of the framing, like fixed size framing and variable size framing. And the next topic is the what are the methods for dividing the frame. We divided as a different frames, right? So what are the different methods for dividing these frames? Those are the 4 methods for dividing the starting and ending of each frame. Those are the first one is the byte count, or it is also character count. It is also called as character count. And the next one is the flag bytes with byte stuffing, flag bytes with bit stuffing, physical layer coding violations. These are the 4 methods for dividing the frames. First, we will see what is byte count, or it is also called as the character count. It is nothing but character count. So, how byte count is going to be happened for dividing the frame? See, in this byte count method, the frame is having the header field. It is having the header field that are going to be used mainly. Why we are using this header field? For identifying the number of bytes in the frame. How many bytes are there in that particular frame? Means we are counting byte count, right? So that how many number of bytes are there in that particular frame, we are going to use the header field. This is nothing but the byte count field. So when the frame is reaches to the receiver check the byte count. Based on that only, it determines the number of bytes are there. How many number of bytes are there in the frame and what is the starting and ending of the frame. It will understand the receiver. So see this example here. So here total, suppose here it is A is having frame without error and B is having frame with error. How it is going to be happen here? See once. Suppose in this first frame, if it is a frame 1, here how it is going to be counted total. Here 1, 2, 3. These are the 3. And coming to including this, it is having how many are total? 4. This is the 1 frame. Till here it is 1 frame. And coming to here it wrote what? 4. This is the header field. What this is? It is the header field, means saying the total number of bytes in that particular field. So here it is saying that 1, 2, 3, 1, 2, 3, and including this it is also 4. Here 1 frame is completed. And coming to frame 3 till here, right? See total how many are there? 1, 2, 3, 4, 5, 6, 7, including this 8. Total it is having the 8 bytes. Like that the frame is going to be divided. So there is no errors in this particular frame. That's why it is the frame without error. Like that it is going to be considered. So it is header field. It is telling that the frame total length means total is how much it is having? 1, 2, 3, and including this it is 4. Like that it is going to be understand. And coming to a frame with an error, how the error is going to be identified. So instead of that writing, if the what is the binary value of the 4 is nothing but 100. Instead of writing this binary value, 1 bit is going to be changed during the transmission. Whenever the data is transmitted from sender to the receiver, that may be chance to happening that and there may be 1 bit is changing for the duration. So where it is going to be changed, 0 is changed to 1. So the binary value of this particular is the 110, that is nothing but the 6. So here what it will understand, instead of 4 it will understand what it is having 6. So how the framing is going to be understood? So first it is the frame 1, right? It is having 1, 2, 3 means next after including this it is having 4. It is okay, this is fine. And coming to next one, it is 1 bit is changed, right? Because of that it changed as the 6. So till 6 it will consider 1, 2, 3, 4, 5. Till here it will consider, including this it is 6. So till here it will take. And coming to next, it is having the 0. 0 means what it is, what this header field is saying, the in next whatever is there is no nothing bytes are there. So it will discard it, means there may be error will be happened. So wrong byte count is happened. So that is nothing but the frame with one error. Here it is frame without error. Here there is no error. Here error is there. Like that byte count is going to be happened in the data link layer. And next one is the flag bytes with the byte stuffing. What is flag bytes with byte stuffing? Stuffing is nothing but adding. How we are going to add the flag bytes with byte? Again we have to add the bytes only. How we are going to add? So each frame starting and ending we have to add the special bytes. Those are nothing but the flag bytes. If the flag byte is there in the frame, we have to add the extra escape. If the flag is having in that particular frame, we have to add the particular escape to that particular frame. When the data link layer receives the frame, it removes the escape. Means if it comes to the receiver side, again it will whatever escape is added, that is going to be removed escape from the frame and send them back to the network layer. This is known as the byte stuffing. So how it is going to be happen, we will see in this example. And also it is having the data contains escape, we will add another escape. Suppose if flag is there, we are adding escape. If escape is there, again we have to add the one more escape to that particular frame. The main thing is we have to add the wherever first starting and ending we have to use the flag. That is the first one. And the next one is the whenever the flag is there, we have to add the one escape. At the same time, whenever the escape is there, we have to add one more escape also. That is the condition. Flag bytes with byte stuffing. See this example, the structure of the frame. Flag is saying nothing but what? Starting and ending of the frame, right? So here header. Header is already we said source and destination address. Data means whatever data is coming from the network layer, those information considered as a data. And trailer is saying about the error detection and correction. This is already we discussed. This is the structure of the frame. Suppose in this message, this is the message. Here the flag is there. If the flag is there, what we have to do? We have to add one extra escape byte. So that's why we have to add one escape to this particular message. At the same time, suppose take one more thing. Here the flag is there, escape is there. What we have to do for that flag? We have to add one escape. Again here also we have to add one more escape to this particular flag. So this flag is, this escape is for this flag, this escape is for this. So for escape we have to add one more escape. For flag we have to add one more escape. That is about flag and escape. And coming to next example, that is this example. Escape is there, escape is there. For this escape we have to add one more escape. For this escape also we have to add one more escape. See here in this example, for this we have to add one more. For this we have to add one more escape. After stuffing, this is before stuffing, this is after stuffing. Stuffing is nothing but adding. What we are adding? If the flag is there, we have to add one escape. If the escape is there, we have to add one more escape. So whenever the receiver is receiving the frame, then that time it will remove the escape bytes. That is about the flag bytes with byte stuffing in data link layer. And next one is the flag bytes with bit stuffing. Previously what? Flag bytes with byte stuffing. It is flag bytes with bit stuffing. We have to add with the bits. Add with bit stuffing. Okay. So here we have to see first of all, framing done with instead of bytes, we have to use the bits here. The flag byte started and ending with a special sequence of bits. Whatever flag byte starting is there, we have to start with starting and ending with some particular sequence of bits. These are the sequence of bits. Here what is there? 0, 0, 1, 1, 1, 4 ones after 0. This is the sequence of bits. Starting and end, we have to add this. See this example. And starting and ending, I am adding with 0, 1, 1, 1, 1, 0. And starting ending also 0, 1, 1, 1, 1, 0. The what receiver will understand if we add these particular special type of bits. So this is the starting and this is the ending of the frame. Like that it will understand. This is the start of the frame. This is the ending of the frame. For that reason we have to add the special type of bits. Those are this one. The well-known example of this method is nothing but the universal serial bus. In a universal serial bus, we are adding like this only. The physical layer maintains the synchronization of the bits using this particular method only. How this particular method is going to be used? See this example. So this is the original data. This is the original data. This is the starting and ending because we are adding some sequence of bits to this particular frame. That is starting and ending. So the data link layer adds the bits to the 0 after 5 consecutive ones. Here all 5 ones are only there. All ones are only there in this particular frame. So whenever the data is sending to the sender to the receiver, what it will do means when after 5 particular ones, after 4 ones it is 0, right? That's why it will take after 5 ones, after 5 consecutive ones, it will take 1. We have to stuff with 0. Means see here this is the starting, this is the ending. So after 5 consecutive ones, 1, 2, 3, 4, 5. After 5 we have to add 1 0. And next after 5, 1, 2, 3, 4, 5. Again we have to add one more 0. And next finally 1, 2. 2 ones are there. Like this we have to write. After 5 ones we have to add 1 0. We have to stuff 1 0. That is the bit stuffing. The receiver, how the receiver will understand this? The receiver will remove the zeros that are followed by 5 consecutive ones. What is the means exactly aim is nothing but we have to stuff with the bits. Why we are stuffing like this? During without error free means there is no errors. For that reasons we are adding these stuffing methods. So here this is the starting, this is the ending. Here whatever extra bits we have added, right? Zeros that are removed by the receiver. And finally the original data is received from the receiver. That in the data link layer, that data is again sent to the network layer in the receiver. This is the process of the flag bytes with the bit stuffing in data link layer. And the final one is the physical layer coding violations. What is physical layer coding violations here? Whatever the message is there, that are going to be encoded by encoding method in a such a way that both sender and receiver can be recognized it. We have to use the encoding method that will understand by the sender and receiver. How it is encoding and decoding happen means, this method is mainly providing some reserved signals. It indicates the starting and ending of the frame. At the same time, it is called as the coding violations. Delimit of the frame to the data link layer. So we can apply these reserved signals to the original data sent by the sender. So there is no problem the receivers to identify the data. So how exactly it is going to be happen? See, consider as a Lance encoding method. Here it is each of the bit data is represented by two physical bits. That may be 00, 01, 10, 11, like that. Two physical bits it is going to be divided. So if suppose 11 is there, it is considered as high. If it is 00 is there, that is low to low connection. These are the error codes. If it is there, if 11 is there, 00 is there, these two are not used. These two are not used. 00 and 11 is not used because these are having the errors. And coming to remaining two, that is 0110. When we are using high to low, low to high means, if it is 1 is there, if it is, we have to encode. If 1 is came, we have to replace with 10. That is high to low. That is high to low, we have to replace. Wherever 1 is coming, we have to replace with 10. Wherever 0 is coming, we have to replace with 01. That is low to high, we have to write. We are not using 00 and 11, we are not using. So this is in the Manchester encoding. This is about the physical layer coding violations in data link layer. These are the different methods for the framing. And coming to the summary, what we discussed today. First we discussed what is framing. And next we discussed what are the different fields of the frame. Fields, like whatever fields are there exactly, that are discussed in today's topic. And next we discussed what are the different types of the frame. Fixed length, variable length frames, those are going to be discussed. And what are the different methods are there for dividing the frames. Like we discussed what is byte count, what is flag bytes with byte stuffing, what is flag bytes with bit stuffing, what is physical layer coding violations. These are discussed in today's session. Thank you.